So to carry on with part D, we'll find the y component of the total electric field. We've already found the expression for the element of the y component, our dEy. So now to find our total y component, we'll integrate this part over the length of the rod. So our Ey equals the integral of dEy. We'll fill in what we had for our dEy from the previous part. So here's our dEy that we found in part C. We'll fill that in now that we're in part D. So it's the integral of k times lambda times y times dx divided by x squared plus y squared to the 3/2. So we'll take our constants out front. K and lambda and y are all constant. Y is your height above the rod. That's constant at 1 centimeter, so that can come out front. So k times lambda times y outside the integral y times dx over x squared plus y squared to the 3/2. Limits of the integral are the same. We go from one end of the rod to the other, so we go from L to 0. We can look up this result in a book. When we look it up in a book, we find that it's k times lambda times y outside of x over y squared times the square root of x squared plus y squared. That's evaluated at 0 and L. So we'll put in our 0 first. We get k times lambda times y outside of 0 over y squared times the square root of 0 squared plus y squared minus L over y squared square root of L squared plus y squared. So we just put in L for our x values there. This whole bit is gone because we've got 0 divided by a number. So we'll carry on here. So we've got k times lambda times y times minus L over y squared square root of L squared plus y squared. We'll put in our numbers here to solve for this. So we have minus 8.99 times 10 to the 9. Our lambda is 5 microcoulombs, 5 times 10 to the minus 6 over the length, 0.10 meters, times y, 0.01 meters or 1 centimeter, times L, 0.10, divided by y squared, 0.01 squared, times the square root of L squared, 0.10 squared, plus y squared, 0.101 squared. Okay, before you hit the calculator, you can probably notice that you can simplify a little bit. This 0.1 cancels with this 0.1, this 0.01 cancels with that squared. So just a little bit fewer buttons to push on the calculator. And what we get here for an answer is minus 4.47 times 10 to the 7 newtons per coulomb. We think about our negative sign. We ask if it makes sense. We look at our picture and we see that the electric field, the y component points up. It's positive. So our answer here is a result of the way that we picked the limits of the integral. We know it has to be positive. So now to finish, we just write out our answer. So the total electric field E is equal to the x part, minus 4.05 times 10 to the 7, that's in the x direction, I, plus the y part, 4.47 times 10 to the 7, that's in the y direction, so J. Then we add the units, newtons per coulomb. And there's the net electric field at point P.